Hi, this is Chen from Team134. So the problem we're trying to solve here for our target audience is they're typically students in the early stage of their job application and learning. A student may know some keywords and they may know the occupation they're studying towards, but they can't pinpoint the exact class or the exact platform to start their research. So we're building a visualization and recommendation systems to help these students navigate large catalogs of online courses in hundreds of thousands of rows across different learning platforms such as Udemy, Udacity, Skillshare. So the two core functionality we're offering here is Course Curriculum Composer, which builds courses off of target occupation the student may want. The second piece is the Course Visualizer to find related courses, where courses are plotted on an XY graph, where similar courses may be next to one another, and there will be a tooltip to show more information on hover, such as the class length and the difficulty and the rating. So the algorithm that powers our product is one is Word2Vec. We do a predictive model. It's a predictive model where the center words and we'll use the surrounding context words as a positive training sample. The model is really doing dot product of each words and context words and applying a softmax to get the normalized probabilistic outcome. Then we take that hidden layer of the neural network, which becomes our embedding vector. And then we're using for our distance metric using cosine similarity. If a occupation vector is similar to a course vector, it may signify the course is relevant to the job they want. And two courses that are highly similar should be placed next to one another on the XY graph. And to do XY graph, we used Tissany to do the reconstruction of our 300 dimensional vector. Since you can't really visualize a 300D graph, so we decided to project that onto a 2D XY graph to help people to help people visualize the courses. So what we did here is we fit the original data set into a Gaussian distribution. Then we rebuild these random points, and we rebuild random points onto 2D space. And each iteration will try to change the projected points to minimize the KL divergence. A low KL divergence means the projection was successful, and a 2D graph and 3D graph have similar distribution. So what's interesting here is on our graph, actually, so a lot of our music courses and art courses are pushed to the left side of the quadrant. A lot of science courses are pushed to the right side of the quadrants. And obviously similar classes are placed right next to one another, as you can tell from the coloring. And we also do an API that supports dynamic querying to search for any class, jobs, and keywords a student may want. And thank you for listening.